And a proportion is simply an equation that says two ratios are the same. Okay? It's an equation that says two ratios are the same. So let's take this one for a minute. 2/3 equals x over 6. Many of you will say, well, to rename it with a denominator of 6, I can simply multiply both pieces by 2, right? And most of you would come up with the fact that x equals 4 that way. But they're not always that easy. What we're going to primarily be using is something we described a little ways back. And I believe it was called the cross product principle, which means cross products, and I'm kind of paraphrasing, fractions of equal value must be equal. So 2/3 is 4/6. You've already told me that because you simply doubled your 3, right? But the cross product principle says that in order for this to be true, the product of this and this, which is 12, must equal the product of this and this, which is also 12. You can use that to solve for missing pieces of a proportion, and that's where we're going to begin in example 1. A says, solve it. 3 over x equals 5 over 4. So this one's not quite that easy, is it? Can you multiply 3 by a whole number to get you to 5? Something nice and simple? No. So instead of using that rename the fraction thought process, we are going to use the cross product principle, which states that if fractions are equal value, then their cross products must equal one another. So let's make the cross products equal one another. 3 times 4, which is 12. 5 times x, which is 5 times x. Let's make those two equal one another. Well, to do that, we're going to connect them with an equal sign. Okay? If this is true, then this must also be true. To solve for x, divide by the factor you know, and you'll find that it's, 2 2/5, but now that you're in algebra, generally, writing fractions improperly is okay. All right? They also have 2.4 in there anyway. All right? What do you guys think of this? Not too shabby, right? It's going to get a little more difficult, but really not that much, guys. You're really not going to be that far off. Okay, example B. So B says 4 over 21 is equal to negative 2 over 15a. Another one where it is basically impossible to figure out the a value using 21 times something, like fractions. But we can use the cross products principle, which states that in equivalent fractions, their cross products must also be equal. The product of negative 2 and 21 is negative 42. The product of 4 and 15a is 60a. guys with me so far? So, based on what I have said, those two numbers must be equal. So we will join them with an equal sign. 60a equals negative 42. To solve, simply divide by 60. And you're not getting a pretty answer here, folks. A equals negative 42 over 60, which reduces all the way down to negative 7 over 10. And yes, you do need to reduce these. Yes, yes, yes. So you're saying, well, that's really ugly. So you're saying 15 times negative 7/10 is what you would put here? Yes. All we're doing, folks, is figuring out what value for A would create an equal fraction with this. Okay? So 4/21 equals negative 2 over 15 times that. You're not going to do anything else with it. It's simply getting the information. C. Every year it seems like people struggle with this one most of all. 3 over n is 8. Well, I have a fraction on one side and I have a whole number on the other. In order to make this method work, what do I have to do under the 8? Put a 1. You're awesome. Cross product principle. 3 equals 8n. N is equal to 3/8. Not much more you can do with it. Not much more you can do with it. When you check the back of the book, if you say this and the book says 0.375, you know they're the same thing, right? Don't worry about it. I don't care if you answer it fractionally or with a decimal, unless it tells you answers must be in decimal form. Otherwise, I don't care. Okay? It's all the same to me. Where it gets a little more difficult is example 2, and this is actually where I'm going to quit today. We're going only up to and including example 2 because we're not doing the word problems till tomorrow. Example 2 says, well, what about this? X minus 4 over 3 is equal to 2 over 15. What's x? Well, in order to figure that out, we're going to use the cross product principle, which says if two fractions are equal to one another, then their cross products must be equal. So 15 times x minus 4 is 15 times x minus 4. Now some of you might already have said 15x minus 60, and if you are there, that's fine. I don't care if you show this, but as long as you recognize that this must be accomplished, you have to distribute. That's the one side. The other side is 2 times 3. That one's nice and easy. Distributing your 15, you end up with something like this. To isolate x, first we're going to get rid of the number that is a whole number. Get it out of there. And to find the missing factor, we're going to divide out 15, and you're going to end up with 22/5 once you reduce it. If you divide this by 3 and that by 3, you get 22/5. How are you guys feeling about this? All right. And letter B. n minus 3 over 5 equals n plus 2 over 6. Wait a minute now, I got a couple of variables here. It doesn't change how you work with it. Okay? Five times n plus 2 must be equal to 6 times 2n minus 3. Everybody good? Let's distribute, shall we? 5n plus 10 5n plus 10 is equal to, you must distribute it over both pieces. If there was one error that I still keep seeing, it's this. When you are multiplying a number or anything here by something that is a binomial, both pieces are receiving that multiplication. 12n minus 18. Now, you need to get all of your n's on one side and your number on the other. So I am going to pull my 5n to the right. Either way would work, but I like to keep my n's positive. So by pulling my n to the right, I still have a nice, pretty positive 7n. So now I have 10 equals 7n minus 18. Some of you might not need to write this piece here. You might already know that you are now going to add 18. If you're one of those people, that's fine. To isolate n, divide by the coefficient, and you should have come up with your answer for being equal to n. It doesn't get any tougher than that. It really doesn't. They're all going to be either the simple version or the more difficult this, okay? It doesn't get any more difficult than that.